The peculiar nature of the offshore environment has necessitated the need for the oil and gas industry to develop durable subsea technologies and better hydrate inhibitors to prevent hydrate formation and assure flow. With the introduction of the mini hydrate flow loop, these problems can be tackled by studying hydrate formation in gas-dominated systems using a constant volume batch experiment. The laboratory loop is a closed loop of 12 meters, fabricated using 0.5-inch 316 stainless steel pipe enclosed in an insulated 4-inch polyvinyl chloride (PVC) pipe. The hydrate loop mimics offshore production in the subsea environment. The steel pipe enclosed in the PVC pipe containing cold water represents the flow line on the seabed, surrounded by cold water. The skid-mounted loop was fitted with pumps, temperature gauges, pressure gauges, differential pressure transmitters, a gas mixing vessel, an inhibitor mixing vessel, and a natural gas cylinder. The experiment starts by pumping 435 milliliters water into the steel pipe to raise the loop pressure to about 25 psi using pump 3. The cooling water generated from the refrigerator is then pumped around the annulus of the steel pipe and the PVC pipe, using pump 2, to progressively reduce the loop temperature to hydrate formation temperature. Natural gas is injected into the loop to achieve a pressure of 150 psi as a single batch. The screw pump is turned on to cause agitation in the flow line. The temperature and pressure around the loop are recorded every minute during the 2 hours experiment. Hydrate formation is indicated by 1. Reduction in flow viewed from the transparent flowmeter. 2. Rapid rise in temperature caused by the exothermic reaction of hydrate formation. 3. Rapid decrease in the final loop pressure, caused by the natural gas being used up to form hydrates. 4. An increase in the differential pressure between the inlet and outlet of the refrigerating unit due to hydrate crystals forming around the inner pipe walls. When testing hydrate inhibitors, the inhibitor is mixed with water and pumped into the loop to make up the 435 milliliters. The gas is injected to increase the loop pressure to 150 psi, and the cooling water is circulated around the loop. Inhibitor effectiveness is indicated by 1. No reduction in flow viewed from the glass flowmeter. 2. No spontaneous rise in loop temperature due to the absence of the hydrate formation exothermic reaction. 3. No significant drop in the final loop pressure because the inhibitor prevented the hydrate formation reaction between the gas and water. 4. No significant change in the differential pressure between the inlet and outlet of the refrigerating because the inhibitor effectively prevented hydrate formation in the pipe walls. The mini hydrate loop can adequately predict hydrate formation in gas pipelines and can be used in screening and selecting kinetic hydrate inhibitors.